Hello, it is John Barrett, founder of Sustainable Engineering. It is 8 a.m. and we have just arrived at Move 2025. Behind the doors is an exhibition hall full of engineering companies that are developing new technologies, new products, new services, new processes, all aimed at improving the sustainability of the mobility sector. So we're going to be charging around that hall throughout the day. We're going to be looking for shiny new technologies on those stands. We're going to jump onto those stands. We're going to conduct lightning interviews with the specialists and executives. We have just come onto the Bosch mobility stand, and I'm talking to Andrea, and we can see right behind us here, fleet sustainability. So I thought we'd offer Andrea the opportunity just to give us some background on what that means, what the benefits are of this, how Bosch Mobility is delivering this type of sustainability, and what it means for their customers.
So for Bosch, sustainability is a very important topic, and especially when it comes to fleet services, what we exhibit here on the Move. It makes a real difference, not only by increasing the fleet sustainability in daily operation, but also to foster and facilitate the use of electric trucks, for example. So when we at Bosch talk about sustainability in a fleet, let's say, setting, we, for example, offer services that do a very precise range prediction, so that with your truck you can come from A to B and you can replace a combustion truck by an electric truck. Also, we have a technology where we can facilitate the use of alternative fuels, which can have a very positive impact on the overall CO2 reporting that is already, let's say, reality today, but will be, at least in Germany or in Europe, reality also in the future. And then, of course, we're always trying to also increase efficiency for the traditional combustion vehicles. So there is one technology that we call retrofit efficiency module, which can increase fuel consumption by up to 4%, even though there is cruise control embedded.
When you were talking about alternative fuels, are you talking sort of biofuels, hydrogen, maybe, obviously electric? So all of those fuel types, yeah? Yeah, cool.
Yeah.
Okay. Excellent, thank you. We've jumped onto the Dassault Systems stand, and we are looking at a fascinating vehicle computer-aided design system, I guess I would describe this as. Web-based. We're looking here at a sustainability angle. And in particular, we've just jumped into here. I've just had a demonstration on this, really interesting. And what we're looking at is weight and balance, for example. So initially there was a bill of materials of the vehicle. There was a target weight, hypothetical vehicle that was slightly overweight. And that bill of material allowed me to identify elements of the vehicle that offered opportunities for weight reduction. So we jumped into a more detailed view, and we've taken a look at a battery pack, and there was a desire for this vehicle to reduce the weight of the battery pack, so it brought the bill of materials total weight down, and a new battery pack was designed, new materials, new design concepts, etc. And then the two batteries are now comparable, so the engineers can see the comparison between these two. There's now a bill of materials of the battery itself, so we can see which components and materials were retained, which were redesigned and swapped out, and what the weight comparison is between those two components. And that is possible for all of the parts and subsystems in a vehicle, so you can get a system-wide view of the weight and balance of a vehicle and how certain components and subsystems, such as the electrical system, high voltage system, etc., could contribute to weight reduction through further design and innovation. So it's a kind of live, real-time visual interface of a vehicle as it moves through the development process, allowing engineers across the team to see where R&D is being targeted, what the results of that R&D are, how that R&D is impacting the vehicle as it moves through its development cycle to arrive at a more sustainable product. So we think this is pretty cool, and we'd like to see more of this. And so we'll be staying in touch with Dassault Systems, and hopefully we can do a write-up for the magazine in more detail. We can interview some of the engineers and do a deep dive into this on a later date. I am on PQC Technologies stand, and I'm with Jason. And what caught my eye was the polycarbonate glazing technology. One benefit of which, obviously, is to reduce vehicle weight, which in dynamic applications contributes significantly to energy reduction and sustainability. This is some pretty serious tech here in terms of the material, the surface coating, processes, etc. So I'm going to hand over to Jason. I'm just going to ask him to give us a rundown of the technical benefits of this material, what's unique to this company, and how that's contributing to a more sustainable mobility environment. So Jason, over to you. Just give us a rundown of what we just spoke about.
Sure. Well, I guess the most obvious factor is the shapes that we can get with polycarbonate. We can get more form into this material than you can with glass. Like you said, polycarbonate is 50% lighter than glass. So, for example, something like this L7E microcar here, when we changed from glass to polycarbonate, we took 50 kilos out of that vehicle. And that vehicle actually has a legal weight limit of 450 kilos.
Right.
So it's a massive savings.
Yeah.
One of the only parts that you can save that kind of light weight.
Right.
But like I was saying as well, we also have been developing our coating technology. We now have Quantum Plus, which is super hydrophobic.
Okay.
But it's so hard that it's equivalent to glass now. It actually exceeds what glass can do.
Okay.
It's diamond hard. But it also gives you amazing water shedding abilities.
Good.
So yeah, we've developed all this IP. We've been in the polycarbonate market since 1970, and most of what you see in polycarbonate we developed. Like we do inks under the coating,
Right.
and it's silk screened onto the polycarbonate.
Okay.
We do that when it's flat, then we form it. Once you've got the coating on, it's like a painted part. It looks amazing,
Right.
but at the fraction of the cost.
Okay.
And without all the, sort of like recycling problems that you have with paint.
Yeah. And so you mentioned about the surface coating, so that's going to contribute to both safety and durability.
Yes.
So as durable as glass, half the weight. And you were talking about thickness as well.
Yeah.
You get thickness down on that compared to
Yeah,
glass.
your typical glass windshield will be 5 to 6 millimeters thick. We can reduce that down to 3 millimeters. If you're putting a windshield wiper on the windshield, depending on the style of the windshield, you might have to go up to 4 millimeters, but you wouldn't have to go any thicker than that.
Brilliant. Sounds like fascinating technology.
Very
pleasure
good.
speaking to you. Thank you very much.
No problem.
Okay, I am with Sebastian on the Circunomics stand, and here we are combining circular economy, electrification, battery technologies, software, marketplaces, all to revolutionize and transform the way batteries are monitored and dealt with throughout their life. So I'm going to hand over to Sebastian and get him to talk us through the two services that they provide and how that's going to contribute to a more sustainable mobility sector. So over to you, Sebastian.
Thanks, John. So what Circunomics is doing, we are dedicated to achieve a circular economy for batteries. We do that with two products. We have a marketplace for battery, a B2B marketplace. Think of it as we are sort of the Amazon for batteries. You can buy and sell battery cells, modules, packs, new ones, used ones, second life, but also end of life once the batteries go into recycling. So that is the first product. The second product is battery analytics. So we monitor batteries in the field, we take the data from the battery management system, and with that data we can predict how much life is in that battery, and when that battery should go into a second life, and when the battery is sort of at the end of life and needs to go to recycling. And by doing that, we want to achieve a full circular economy for batteries.
Absolutely fantastic. Thank you for that succinct summary. We're going to keep a very close eye on what you guys are doing because our magazine focuses on electrification, also the mobility sector where energy consumption and weight reduction are important. So we're interested to find out what's going to be happening to batteries through their life. So it looks like if we keep an eye on this, we're going to get a good indication of what's going on. In terms of multiple lives of batteries, stuff we've looked at before, moving, say, from an automotive application to maybe an industrial application to maybe energy storage or home storage and then end of life. Is that the sort of process that you imagine they'll be going through?
Yes, and that's what most of our clients are doing.
Yeah.
So in our marketplace, we currently have 5 gigawatt hours of batteries.
Okay.
Most of those batteries are coming from an automotive application.
Yeah.
This could be overstock, meaning the OEMs purchase too many batteries and now want to get rid of them. But this is also proper second life batteries, modules and packs that will then go into battery energy storage systems. So basically the containerized battery for industrial usage or grid usage.
Yeah, brilliant. Okay, I am on the KINTO Zero stand and I'm with Shahin, and we're going to talk about the software platform that this company has developed, specifically designed to reduce the environmental impacts and improve the sustainability of mobility. And interestingly, talking to the company here just now, one of the application areas, for example, would be the movement of people during shift swap overs at manufacturing facilities. Now, a lot of our readers, a lot of our audience are engineers working at big engineering organizations. And if they're manufacturing facilities, then they're going to need to move a lot of people in and out at the end of the shift. How is that best done from an environmental and sustainability perspective? So the software that these guys have developed allows you to create a baseline of the environmental impacts of that mobility and movement of people at the moment, then to put a plan together as to how that might be reduced, then to implement that plan, and then to record and report. Is that a fair description?
It's a fair description. It's a bit more complicated. In the identify stage, we are really creating a baseline around every aspect of your mobility, commuting, business travel, and your fleet. Then on the plan, we have developed like an algorithm that enable you to project the impact of your implementing mobility incentives. Okay. So promoting, like, let's say for commuting, carpooling, walking, cycling to your employee, and see the impact that will have in your reduction. On the next step, implement. We're providing you with all the application. For instance, the KINTO Join mobile app for reducing your commuting emission, and then gamifying the fact that you are doing all of this with your employees. Yeah. So this way, they need to have a reason to do it. Yeah. And sometimes, sadly, sustainability is not good enough. So in that case, we're really trying to gamify things with the company, trying to see what's important for them. You mentioned parking. Yeah. Parking could be a very big reason of why people will use the platform. And let's say if you carpool, you get a prime parking spot. Especially relevant also in airport, mentioning shifts, where you can end up walking 20-30 minute walk from your place of work, adding to your commuting, and then in that case you get the prime parking spot, like 5 minutes away. And all of this is monitored almost real time. So as a manager, you have the information of how many people carpool, how many incentives you've given, and all of this. So that's really like all this feedback loop that is constant, and then remeasuring the baseline on a 6 months yearly basis, trying to find new ways to reduce your emission. That's what we're about.
And at the end of that process, we spoke about the reporting, where large organisations across Europe now with things like CSRD, including Scope 3 type reporting, which they probably haven't done before, that can help feed into that into that data.
So we even have, like, and that's what also the big bit of KINTO Zero is about. It's completely in line with CSRD reporting, using the technology required by the European Union, XBRL, and you can report on all your ESG. The benefit that we have is that we already have a lot of integration already made with what you will find about your managing your fleet, managing your commuting, managing your business travel. All of this is already integrated, so all the data is already fed in. So you don't have to do all the extra step. Of course, there is effort to do on the social side and the governance side, but we are really streamlining the process.
Okay, I am on the ReBattery stand, and I am with Luke and Alex. and we're taking a look at the subject of battery recycling in the mobility industry. They've got a software platform here they're going to introduce us to, which is based around understanding the condition and status of batteries, and then making sure that they end up in the right channel for reuse. So it may be reuse, it may be end of life, etc. I'm going to hand over to these guys and they can give us a little bit more information on the origins of this, how the platform works, and really what problem is someone facing where this would be the solution. So over to you guys.
Great. Thank you for the introduction. So electric vehicles are skyrocketing at the moment, and companies are wrangling to say, okay, well, what do I do with my batteries that come back from customers? And, you know, how do I find a recycler? How do I find a repurposer? That's where we come in. We handle everything for the companies. You just tell us what batteries you have, and we connect you to a global network of battery recyclers and repurposers. We aim to take the risk out of handling the batteries as well, and we also help you to get the most value from your batteries.
Yeah, we're the one-stop platform for you to get rid of your battery recycling headache, and we hope to make the market here more circular by finding the second life options that often could exist for batteries, but oftentimes batteries are getting recycled when they still have a lot of use. So this is what we're very excited about.
And we have got a fascinating story here. We're looking at a folding electric bicycle, innovative in its own right, but from one angle for our audience who are engineers interested in material science, is the way these components are being manufactured, because these are manufactured from essentially a glass fiber reinforced plastic. And I'm going to hand over to Chad now to explain how these parts are produced and how they contribute to the recycled content of these particular bicycles. So Chad, just explain a little bit about this material and how it's produced.
So this material, it's a recycled biocomposite, SMC. It's a mix of fiberglass and vegetable resin. You can make millions of different mixes depending on if you need it stronger, more flexible, lighter, whatever. This mix took us quite a long time to find, but it has the right mix of strength, and it's similar, a little lighter than, say, the aluminum equivalent. It's produced to sort of make a Play-Doh-like material. You weigh it out, put it on the press, and 8 to 10 minutes later, 2 pieces come out.
Right, I am on the Westra stand and I am with Mark, and we are looking at a material innovation related to lithium batteries, and in particularly the binder. Now, we've been writing a lot about PFAS recently. There's regulation going through regarding the preventing the use of PFAS. One area where innovation is taking place right now, exclusively by the sounds of it, but Mark will explain it, is in lithium batteries, because what I wasn't aware was that the lithium micrograins are typically bound together with a PFAS material, and at the moment there isn't a replacement for that, but there's one on the way. And so I'm going to hand over to Mark now, and he's going to introduce the technology and the innovation that we're talking about.
Yeah, absolutely. You are totally right. So when you check all the batteries that you have in your laptop, in your phone, in the camera that you are holding, the lithium-ion battery contain a PFAS material. It's called PVDF, and it's the only alternative that you can find on a large scale at the moment. So of course, this is really restrained to any upcoming ban. So we have a polymer that is actually not a PFAS and that can replace one-to-one this solution. And it has additional benefit, like the impact, ecological impact is much easier. You have nicer solvent to play with, so the impact on the production of battery would be much simpler with our solution.
Just explain where the company and the technology is at the moment in terms of your roadmap. When do you think this will be sort of commercialized?
So at the moment we are on the pilot phase. We are discussing with the automotive industry. Of course, if you want to go to the EV industry, it takes a lot of time. You need to have a lot of regulation to overcome. But we are discussing with big companies in the automotive industry to try out and validate this technology.
Okay, thank you very much, Mark. Fascinating technology, and we wish you well, and we will keep an eye on how you progress.
Yeah, thank you very much.
Thank you. I am here on Nanomade stand with Claire, and what caught our attention was quantum sensors, which sound pretty cool. So we stopped to take a look, and these are, in essence, very, very sensitive force sensors, which have multiple applications in different industry sectors, but they've got some interesting sustainability angles. One is the fact that they can be mounted on the rear side of an enclosure or a switch housing or something like that, even if it's metal, because they're so sensitive, which means that they are going to improve the reliability and durability of products because they're removing the need for mechanical buttons and standard HMI type interfaces. There's also an angle in terms of predictive maintenance, because they can be built into engineered systems, monitoring the health of systems with vibration and stuff like that. That can go into an AI app and start to predict maintenance of a product. But also they can be mounted, I'm just going to have a look at this one. They can be mounted adhesively to the inside of a user interface. So when it comes to recycling at end of life, they can just be peeled away. To make the recycling process simpler. Now, in terms of the actual technology, I'm going to hand over to Claire and ask her to give us a quick insight into the technology behind these sensors.
Hello, so we are manufacturing sensors, ultra-sensitive deformation sensors. So it's printed electronics technology where we are using our own developed ink loaded with nanoparticles. The ink is printed onto a substrate, flexible substrate with conductive electrodes. And when there is a slight deformation of the substrate, there is a tunneling current occurring between the nanoparticles, and this quantum effect is bringing very high resistance variation, so a very high level of performance that is hardly reached by other technologies on the market today.